Hi, I'm Professor Shuck from CCM's Math Department. In this video, we're going to talk about the law of sines. In engineering, there's going to be many occasions when you will need to find the measures of angles. For instance, in this problem to the left of the screen, this came from a CCM dynamics class. You're being asked to find the angular velocity and acceleration of a link in this mechanism. Now, to find the answer to those two questions, you end up having to solve for a multitude of different angles just to answer those two questions. So that's why we're going to be talking about the law of sines today. So if you're dealing with right triangles, you're generally going to rely on the Pythagorean theorem to help you find information about the triangle. However, if you've got oblique triangles like you see in the two diagrams here, you're going to need to rely on the law of sines and the law of cosines because the Pythagorean theorem won't apply because there's no right angle within the triangle. So that's what we're going to be talking about today. Now, as you know, any triangle has three sides and three interior angles. So given three of those six elements, with one exceptional case, given any three of those elements, we can find the other three using the law of sines and the law of cosines. Before we get started, though, we're going to talk about a naming convention that will help us talk about the law of sines. It's very simple. You just name the angles with a capital letter A, B, or C. It doesn't matter which angles which, just name your angles A, B, and C. Then what does matter is that the side opposite a particular angle is just the lowercase letter corresponding to the name of the angle. So for instance, the side opposite angle capital A is lowercase a. The side opposite angle B is lowercase b, and so on and so on. So this is the naming convention that we're going to use to talk about the law of sines. So what is the law of sines? The law of sines tells us that side, and I'm going to try and speak very distinctly here, side A, the length of side A is to sine of A, angle A, as side B is to the sine of angle B, as side C is to the sine of angle C. So it's just a proportion, right? So as long as you know one ratio here, so if I know side A's length and angle A's measure, I've got a known ratio. I can use the law of sines. So for instance, if I know side A or angle A, angle C, side A, I now know everything I need to know for this ratio. And given my third element, I can find the other three. So that's what the law of sines is going to let us do. So let's look at an example. So in this example, I've been given two angles and a side. So the first thing I'm going to do is I'm going to label everything. So I'm going to use my naming convention, and for no particular reason, I'm going to call this angle A, this angle B, this angle C. And then for a very particular reason, I'm going to call the 20 centimeter side A, because it's opposite angle A. The side opposite angle B is going to be lowercase b, and the side opposite angle C is going to be lowercase c. Okay, so we've named everything. Now, the first thing I'm going to ask myself is, do I have a known ratio here? And I do. I know side A and I know angle A. So I know I'm going to use the law of sines. If I did not have, if the information I was given, the three pieces of information I was given, did not allow me to have a known ratio, it didn't provide me with a known ratio, then I'd be talking about using the law of cosines, and that's another video. But for now, we do have a known ratio. We're going to be able to use the law of sines. Okay, before we do that, though, we're going to do something very simple to start with. We're going to find the measure of angle C using the concept that the sum of the interior angles of a triangle is 180 degrees. So 180 degrees minus 38 degrees minus 102 degrees is going to give me the measure of angle C. So angle C is just 40 degrees. Okay, so one thing known. Now the next thing I'm going to do is I'm going to find, well, let's go ahead and find side B. It doesn't really matter. I'm going to find side B. So I'm going to use my known ratio to do that. So I'm going to set up my little proportion. B is to sine B as A is to sine A. Okay, so B, little b is what we're looking for. I know capital B, that's 102 degrees. That equals 20 centimeters, that's side A, over sine of angle A, so that's the sine of 38 degrees. Okay, so everything's known except for side B. So I solve for B. And I plug this into my calculator. So two things, make sure your calculator is on degree mode, right? So make sure your calculator is on degree mode, and also put it all in at once. Don't write down any partial information. So when you put this into your calculator, I'm going to make the arbitrary decision to round this to 1 decimal place. You'll do what you need to do in your problems. But for this particular example, I'm just going to round to 1 decimal place. So that means I'm going to write down the result to 2 decimal places. So I have 31.77, and then I'm going to use that to round to 1 decimal place of 31.8. And we were given length in centimeters, so this is going to be centimeters. So we now know B is approximately 31.8 centimeters in length. Okay, so the next job is to find C, the length of side C. Now, let me make a comment here before we switch to the next page. In finding the length of side C, I could use the ratio, what? I could use the A to sine A like we did here, or now I have a whole nother ratio, B to sine B. But why am I not going to use B to sine B? Because that involves a rounded number. A, little a, and big A were given to us. So they're as precise as we're going to get. We haven't rounded them in the process of doing any calculations. So I'm going to continue to use the ratio A to sine A so I get the most precise number I can. So we go over here and we're just going to do the same little calculation to find side C. So side C is to sine C as side A is to sine A. Fill in what we know. So C is to sine of 40 degrees as 20 is to sine of 38 degrees. So C is sine 40 degrees times 20 divided by sine 38 degrees. Okay, same process. Make sure your calculator's in degree mode, which it still should be, and write down one more than the number of decimal places that you want. So I'm going to write down C, let me make that approximately equal to 20.88 because I want 1 decimal place. So C is approximately 20.9 centimeters. Okay, so let's just do one quick little sanity check here. What did we actually find? We found that C is 20.9 centimeters, and we found that B is 31.8 centimeters, and we found that angle C was 40 degrees. So one little sanity check we can do here, a reasonableness check, let's call it, is if I take the largest angle, the 102 degrees, the side opposite it needs to be my longest side, right? So opposite of the 102 degree angle is my 31.8 centimeter side, which is the longest side. So that jives. Now, what about the shortest side or the smallest angle? It's 38 degrees. So side A should be my shortest side. Is it 20 centimeters as opposed to 20.9? Yeah. So, you know, that doesn't tell you if your answer is right for sure, but it tells you, it gives you a little bit of a reasonableness check. Okay, so let's look at one more example. So here we've got an acute triangle, and I again have two angles and a side. But if I look at this, I don't have a known ratio. And let's even define the names on my triangle here. So I'm going to use a little bit of a different order this time. So I'm going to call that A, I'll call this B, I'll call this C, and then just label the sides opposite. So this will be side A, B, and C. So once we've done that, you see, we know side B, but not angle B. We know side A, or we know angle A, but not side A. We know angle C, but not side C. But that's okay. Because why? Because we can use the fact that the sum of the angles is 180 degrees to find angle B, and then we will have a known ratio, and we will be able to use the law of sines. So just real quickly, we can say B equals 180 degrees minus 82 degrees minus 54 degrees. So angle B equals 44 degrees. So once we know that, we have a known ratio. And we can find everything else we need to know using the law of sines. So I'll leave that to you to try on your own. If you do try it on your own, side A rounded to 1 decimal place is going to be 22.8 meters. And side C rounded to 1 decimal place is going to be 18.6 meters. All right, well, that's it. Thank you very much.